Since temperature calibrations can be incredibly time-consuming, automation is key to improving efficiency in your processes. The Additel 286 Multifunction Reference Thermometer Readout is the ultimate tool for measuring and calibrating SPRTs, RTDs, thermistors, and thermocouples, with fully customizable programs to make these calibrations as easy as possible. This video will take a look at how the Additel 286 can be used as both a temperature bridge and measurement device to perform a repeatable fixed-point calibration of 5 different temperature probes with as little user input as possible. The ITS-90 subranges used in this demonstration will be 4 and 8, covering the freezing points of zinc and tin, the triple point of water, the triple point of mercury via comparison calibration in a liquid bath, and the triple point of argon via comparison calibration using a liquid nitrogen comparator. To begin, we'll connect a reference standard resistor to the REF2 port on the 286. This 100 ohm resistor is stored in a precision temperature bath held at 23 degrees Celsius and will be used as an external reference to calibrate the 5 probes against. Next, we'll connect a 4-wire cable to REF1. Since all the DUT probes being used have the same quick connector, we will be able to easily swap them out without disconnecting the 4-wire connection. While in bridge mode, the 286 will measure the resistance ratio from both reference ports. Now to set up the calibration test. From the 286 menu screen, select the Application button, then Probe Calibration. Select the plus icon in the bottom right corner to add a new test. These tests are saved to the device and can be revisited at any point in the future. Select the probe type, in this case SPRT. Here we can choose the ITS-90 subranges we will be calibrating, which are 8 and 4 as mentioned previously. Next, we will add the 5 SPRTs that we will be calibrating by pressing the plus button. The name and serial number on these probes should be recorded to ensure accurate traceability. Once all probes have been entered, we will check the Use External Standard Resistance option before pressing Next. Here the test method for each calibration point can be changed, and points can be added or removed using the plus or minus keys. We will use fixed point tests for the zinc, tin, and water calibration points, and comparison tests for the other 2. Specific test settings can be changed here as well, by selecting the calibration point you wish to change parameters for. Once each point is configured to your lab standards, press the Next key. On this screen, sampling and scan settings can be changed for the entire test. Finally, the test can be named and saved with relevant metadata. Press the checkmark button, then the Save button to save this newly configured test. From here we are ready to start, but first want to check that the zinc fixed point cell has reached the freezing point. For this we will select the multi-channel thermometer from the application menu. To change the channel settings, select the tools icon from the top left corner. Here you can select the correct reference thermometer to check the calibration point. You should also connect the reference thermometer to the REF1 wire. Now insert the reference probe, also called the check standard, into the zinc cell. Every few minutes, we will reset the thermometer statistics to resize the y-axis on the screen. This will help us identify when the temperature has plateaued enough for calibration, as shown by the temperature graph leveling off horizontally over time. At this time, you should also insert the first DUT probe in the preheat well of the furnace. With the check standard, we can also see important stability statistics in the top right table, such as average temperature and peak-to-peak difference of the high and low temperatures. We can now remove the check standard and replace it with the DUT probe that was on standby. On the 286, we will go back to the probe calibration application, select our test, and select the first calibration point and probe that we are measuring. After the probe measurements begin, we can set up the next probe by adding it to the preheat well of the zinc cell furnace. Once the 286 has finished measuring the first probe, press the checkmark button to continue. Since we are calibrating the same probe types, we can swap between them using the quick connector. Now we will move the new probe to the active position on the zinc cell. Return to the 286 and select the second probe to begin measurement. These steps can be repeated for the rest of the probes. After measurement, the probes can be moved directly into the preheat well in the tin cell furnace to further reduce downtime. At any time, we can check the temperature of the tin cell as well. One of the advantages of the fixed point program on the 286 is that any probe can be measured at any calibration point in any order. To do this, first save the test cache on the current calibration by pressing the Save icon. You can now close the test and return to the multi-channel thermometer application. After inserting the reference thermometer into the tin cell, repeat the process of waiting for the temperature to stabilize by clearing statistics and checking the average and peak-to-peak values shown on the 286. Once readings have plateaued, we can move probe 1 from standby into the active insert, then return to measuring probe number 3 in the zinc cell. It's important for a calibration lab to determine the optimal order of measurements, stability checks, and standby probes in order to reduce downtime as much as possible. Continue measuring probes for the zinc and tin calibration points. Once finished with all 5 probes, the temperature of each cell should be taken once more with the check standard. Since the next calibration point is the triple point of water, with a much lower temperature than the tin freezing point, it's important to allow the probes to fully cool before beginning measurements. Once they have reached room temperature, we will add all 5 probes to a pre-cooling area in the bath. Since we can confirm the triple point has been reached with a visual inspection of the cell, we don't need a check standard for this calibration point. For this set of measurements, we'll start with the straight probes first. Move the active probe into the water cell, then connect the cable to the 4-wire connection on REF1. On the 286, select probe 4 from the menu to begin measurement. After the probe has been measured, save the test cache, remove the probe from the cell, and dry it off. Swap the connection to the next probe to be measured, add it to the triple point cell, and repeat the process to complete the measurement. After all probes have been measured at the triple point of water, we will move to the triple point of mercury. Instead of a mercury cell, we will use a comparison calibration at -39 degrees Celsius. Comparison calibration points can be used in place of fixed points in order to complete a calibration without having the equipment to actualize fixed points. To replace the intrinsic reference, a reference SPRT must be used throughout the test, which will be compared against the DUT probe readings. Since the -39 degree bath is large enough to fit all of the probes at once, we can connect all 5 of them to the ports on the top of the 286. We will also connect the reference SPRT to the REF1 channel on the front of the 286. Now we can add each of the probes for the automated measurement. Select the first probe section, then add the reference SPRT from a list of preset probes. Then press the next button and add each probe to be measured to the corresponding channels they're connected to. Press the next button again once finished. The 286 will now test each probe signal to ensure that they are working correctly. After that, press OK and the check mark in the bottom right corner to move to the next section. Once you select the play button in the bottom right corner, the test will begin. This portion of the test is fully automated and will end with a pop-up window once all probes have been measured according to the test settings. The next calibration point, the triple point of argon, will also be done using a comparison test by using a liquid nitrogen comparison calibrator at the temperature of roughly -196 degrees Celsius. Once the DUT probes and a reference probe have all been inserted into the liquid nitrogen, the same procedure as the previous comparison test should be followed. First, select the type of reference SPRT, connected to REF1. Then select all of the probes, which are connected to ports 1 through 5 on top of the 286. The 286 will once again automatically measure each probe according to the test configuration set at the start of the calibration. Finally, the DUT probes will undergo one more triple point of water measurement. This will be done using the exact same procedure as previously shown in the video. In the final calculation, both triple point of water values on each probe will be averaged to ensure the probes are functioning normally across both ITS-90 subranges. Once all testing is complete, calibration results can be saved and reviewed immediately. The Additel 286 automatically calculates resistance ratios, ITS-90 temperature coefficients, temperature averages, and more, making it one of the most intuitive and easy to use electrical bridges on the market. These results can then be saved and exported by first inserting a USB drive, then pressing the next arrow in the bottom right. Here the user can enter the file name, the operator name, and any extra notes about the procedure, before exporting by selecting the Save Local and Export to UDisk option in the bottom right corner. Once exported, the data and coefficient calculations will be stored on a CSV file to be easily accessed and organized using any spreadsheet program. The calibration program will also be stored on the Additel 286 to be repeated at any time in the future, improving lab efficiency and reducing downtime. Programs like the ones shown in this demonstration are fully customizable to fit any lab's testing procedures and standards. We hope this has been an informative look at how a temperature calibration can be done with the 286. We would also like to give a special thank you to the calibration team at Acumec Temperature Labs, who made this video possible by providing the equipment, laboratory, and expertise needed to thoroughly document this process. To learn more about the Additel 286 and other amazing products, please visit our website at additel.com.